Remote, that means something which is not exactly in contact or physical contact. Sensing means getting information, data, something like temperature, pressure, photograph, etc. What is remote sensing? Remote, that means something which is not exactly in contact or physical contact. Sensing means getting information, data, something like temperature, pressure, photograph, etc. Remote sensing is the process of acquiring information, detecting, analyzing, monitoring the physical characteristics of an area by recording it is reflected and emitted radiation energy without having any physical contact with the object under study. This is done by capturing the reflected radiation energy. Remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, typically from satellite or aircraft. Special cameras collect remotely sensed images, which help researchers sense things about the Earth. Both images shows diagrammatic representation of remote sensing. Remote sensing in human geography. Remote sensing refers to the process of taking pictures of the Earth's surface from satellites, or, earlier, airplanes to provide a greater understanding of the Earth's geography over large distances. Remote sensing technique. Remote sensing utilizes satellite and/or airborne-based sensors to collect information about a given object or area. Basic principle of remote sensing. Remote sensing uses a part or several parts of the electromagnetic spectrum. It records the electromagnetic energy reflected or emitted by the Earth's surface. The amount of radiation from an object, called radiance, is influenced by both the properties of the object and the radiation hitting the object, a radiance. Spectral reflectance in remote sensing. Land cover and land use maps are required for many applications such as regions planning, landscape planning, and landscape ecology, agricultural management, and forestry. Electromagnetic energy reaching the Earth's surface from the Sun is reflected, absorbed, or transmitted. A basic assumption made in remote sensing is that specific study targets different types of soils, water having different degrees of impurities, rocks of different lithologies, or vegetation of various species, have an individual and characteristic manner of interacting with incident radiation that is described by the spectral response of that study target. The spectral reflectance can be affected by many factors such as soil nutrients, the growth stage of the vegetation, the color of the soil, which may be affected by recent weather conditions. In some instances, the interaction between incident radiation and Earth's surface object will be different from time to time, such as might be expected in the case of vegetation as it changes from the leafing stage, through maturity, growth, and, finally, to senescence. The term, spectral signature, is sometimes used to describe the spectral response curve for a study target. Remote sensing and its types. There are two types of remote sensing technology: active and passive remote sensing. Active sensors emit energy in order to scan objects and areas, whereupon a sensor then detects and measures the radiation that is reflected or backscattered from the target. Radar and LiDAR are examples of active remote sensing where the time delay between emission and return is measured, establishing the location, speed, and direction of an object. Passive sensors gather radiation that is emitted or reflected by the object or surrounding areas. Reflected sunlight is the most common source of radiation measured by passive sensors. Examples of passive remote sensors include film photography, infrared, charge-coupled devices, and radiometers. Types of remote sensing. 1. Active sensor. The sensor embodies within itself the source of illumination like a satellite equipped with a radar sensor. Active sensors throw their own energy to scan the object. Radar and LiDAR are examples of active remote sensing which measure the time delay between emission and return. 2. Passive sensor. The sensors gather radiation that is emitted or reflected by the object or surrounding areas. Sunlight reflection is the most common source of radiation measured by passive sensors. Examples of passive remote sensors are photography, infrared, and radiometers. Passive sensors are more used because it provides great quality satellite imagery. The passive sensor is superior within the field of technical observation of the planet, such as multispectral and hyperspectral technology. What is it used for? Special cameras collect remotely sensed images, which help researchers sense things about the Earth. Some examples are: cameras on satellites and airplanes take images of large areas on the Earth's surface, allowing us to see much more than we can see when standing on the ground. Sonar systems on ships can be used to create images of the ocean floor without needing to travel to the bottom of the ocean. Cameras on satellites can be used to make images of temperature changes in the oceans. Some specific uses of remotely sensed images of the Earth include: large forest fires can be mapped from space, allowing rangers to see a much larger area than from the ground. Tracking clouds to help predict the weather, or watching erupting volcanoes, and help watching for dust storms. Tracking the growth of a city and changes in farmland or forests over several years or decades. Discovery and mapping of the rugged topography of the ocean floor, e.g., huge mountain ranges, deep canyons, and magnetic striping on the ocean floor. Applications. Remote sensing major applications area. Satellites play a huge role in the development of many technologies like world mapping, GPS, city planning, etc. Remote sensing is one of the many innovations that were possible, thanks to the satellites roaming around the Earth. Following are some major fields in what can remote sensing be used for. Weather, forestry, agriculture, surface changes, biodiversity, and many more. The number is damn high, can't list out all. These are the main fields in which it is mostly used. The primary application of remote sensing. Analyzing the condition of rural roads. Rural road conditions are now possible to be analyzed using various GIS technique and remote sensing techniques with an inch-to-inch accuracy. It saves a lot of time and money from transporters. Creating a base map for visual reference. Nowadays, many modern mapping technologies are based on remote sensing, including Google Maps, OpenStreetMaps, Bing Maps, NASA's GlobeView, etc. Computing snowpack. Snow melt ratio can be easily understood by using remote sensing technology. NASA uses LiDAR along with a spectrometer in order to measure the absorption of sunlight. Collecting Earth's pictures from space. Many space organization has a collection containing images of Earth. Interesting patterns of Earth's geometry, including atmosphere, oceans, land, etc., can be seen in it. EO1, Terra, and Landsat are used to collect this data. Controlling forest fires. Information acquired by satellites using remote sensing enables firefighters to be dispatched on time and over correct locations so the damage from such fires can be decreased to minimal. Detecting land use and land cover. Remote sensing technologies are used to determine various physical properties of land and also what it is being used for land use. Estimating forest supplies. MODIS, AVHRR, and SPOT are regularly used to measure the increment-decrement in global forests, since forests are the source of valuable materials such as paper, packaging, construction materials, etc. Locating construction and building alteration. Tax revenue agencies use satellite data in several countries including Greece, Athens, etc. They locate signs of wealth using this technology. Early in the year of 2013, there were 15,000 swimming pools unclaimed to steal taxes in those countries. Figuring out fraud insurance claims. Many insurance companies use Landsat's red and infrared channels to figure out vegetation growth in particular land. This information can be used to verify seeded crops and fight against crop insurance fraud. Observing climate changes. Satellites such as CERES, MODIS, AMSRE, TRMM, and MOPITT has made it possible to observe climate changes from up above the skies. It is also possible to compare past climate situation with the current one. Predicting potential landslides. Landslides cause noticeable death and wealth loss around the globe. INSAR uses interferometry remote sensing technique for providing an early warning regarding potential landslides. Application of remote sensing in agriculture. Identifying crop conditions. Satellite imagery and normalized difference vegetation index (NDVI) technologies are used in order to monitor global food supplies. Healthy crops area reflect green where other areas reflect red or blue. Increasing precision in farming. The health of crops can be measured using remote sensing applications so that almost 10% of fertilizer, money and time can be saved. Determining the soil moisture content. Active and passive sensors of a satellite in space are used in order to determine soil moisture content. Many earth sciences such as water cycle, flood, and drought are based on the content of soil moisture. Crop production forecasting. Remote sensing is used to predicting crop production and yield over a given field and determine how much of the crop will be harvested under the specific conditions. The researcher can predict the crop quantity that will be produced in given farmland over a given period of time. Determining crop damage and crop progress. In the event of crop damage or crop progress, remote sensing technology can be used to penetrate the farmland and determine exactly how much of a given crop has been damaged or under stress and the progress of the remaining crop in the farm. Crop identification. The crop can also be identified using remote sensing technology, especially in cases where the crop under observation is mysterious or shows some mysterious characteristics. The data of the crop is collected and taken to the labs where various aspects of the crop, including the crop culture, are studied. Crop condition analysis and stress detection. Remote sensing technology plays an important role in the assessment of the crop health condition and the extent to which the crop has withstood stress. This data can be then used to determine the quality of the crop. Drought monitoring. Remote sensing technology is used to monitor the weather patterns, including the drought patterns over a given area. The information is used to forecast the rainfall patterns of an area and also tell the time difference between the current and the next rainfall, which can be helpful to keep track of the drought. Water content determination of the field crop. Apart from determining the soil moisture content, remote sensing also plays an important role in the estimation of the water content in the field crops. Crop health analysis. Health analysis of a crop can be also determined, which helps in determining the overall crop yield. Advantages of remote sensing. 1. Large area coverage. Remote sensing allows coverage of very large areas, which enables regional surveys on a variety of themes and identification of extremely large features. 2. Remote sensing allows repetitive coverage, which comes in handy when collecting data on dynamic themes such as water, agricultural fields, and so on. 3. Remote sensing allows for easy collection of data over a variety of scales and resolutions. 4. A single image captured through remote sensing can be analyzed and interpreted for use in various applications and purposes. There is no limitation on the extent of information that can be gathered from a single remotely sensed image. 5. Remotely sensed data can easily be processed and analyzed fast using a computer and the data utilized for various purposes. 6. Remote sensing is unobstructive, especially if the sensor is passively recording the electromagnetic energy reflected from or emitted by the phenomena of interest. This means that passive remote sensing does not disturb the object or the area of interest. 7. Data collected through remote sensing is analyzed at the laboratory, which minimizes the work that needs to be done on the field. 8. Remote sensing allows for map revision at a small to medium scale, which makes it a bit cheaper and faster. 9. Color composite can be obtained or produced from 3 separate band images, which ensure the details of the area are far much more defined than when only a single band image or aerial photograph is being reproduced. 10. It is easier to locate floods or forest fire that has spread over a large region, which makes it easier to plan a rescue mission easily and fast. 11. Remote sensing is a relatively cheap and constructive method reconstructing a base map in the absence of detailed land survey methods. Disadvantages of remote sensing. 1. Remote sensing is a fairly expensive method of analysis, especially when measuring or analyzing smaller areas. 2. Remote sensing requires a special kind of training to analyze the images. It is therefore expensive in the long run to use remote sensing technology, since extra training must be accorded to the users of the technology. 3. It is expensive to analyze repetitive photographs if there is need to analyze different aspects of the photography features. 4. It is humans who select what sensor needs to be used to collect the data, specify the resolution of the data and calibration of the sensor, select the platform that will carry the sensor, and determine when the data will be collected. Because of this, it is easier to introduce human error in this kind of analysis. 5. Powerful active remote sensing systems such as radars that emit their own electromagnetic radiation can be intrusive and affect the phenomenon being investigated. 6. The instruments used in remote sensing may sometimes be uncalibrated, which may lead to uncalibrated remote sensing data. 7. Sometimes different phenomena being analyzed may look the same during measurement, which may lead to classification error. 8. The image being analyzed may sometimes be interfered by other phenomena that are not being measured, and this should also be accounted for during analysis. 9. Remote sensing technology is sometimes oversold to the point where it feels like it is a panacea that will provide all the solution and information for conducting physical, biological, or scientific research. 10. The information provided by remote sensing data may not be complete and may be temporary. 11. Sometimes large-scale engineering maps cannot be prepared from satellite data, which makes remote sensing data collection incomplete.